Welcome to this module of Professor Messer's free CompTIA A+ certification training course on installing and configuring processors. I'm James Messer, and in this video we're going to look at the requirements from 220.702 section 1.1 where we need to install, configure, and maintain processors. So we're going to focus only on those CPUs and those processors that we would use to put inside of our computer. The installation for processors these days is pretty easy. We'll step through the requirements, but there are certain things you should look for. Let's look at this scenario where I have this connector here. This is a ZIF connector, a zero insertion force, where I have an ARM that comes up and I simply install the CPU here that has a PGA package, a pin grid array. You can see all these little holes that make up the matrix of pins that are going right into that. That pin grid array is just going to slide on, but notice it's square, so it's important to know, how is this fitting on? Do I spin it around? Is there a certain way it goes? There absolutely is. Notice that there is a triangle right here on the corner of this particular processor, and if you look closely at the corners of this connector, this on the motherboard, notice that one of these corners has a little triangle on it, or it doesn't have that extra pin that's coming off of that side. So we can know, looking at this, in fact it may even be marked on your motherboard itself as to which corner we should be using for this. Now fortunately the pin grid arrays are designed in a way where it's only going to fit a certain way. Notice on this side we have these two corners are missing pins, these two corners are not. So again, keep in mind we're not forcing this on. If it doesn't simply drop right into this simple connector that's on the motherboard, you don't have it on right. So have a look at the pins in the back, look at the markings on the top, look at the markings on your motherboard, and make sure you're fitting it in the right way. What we'll do is we'll lift up that bar, and that releases the lock that's there on that zero insertion force connector. And we're simply going to just drop it right on top. You don't have to force it in. You don't have to push it. In fact, don't push it. You want to be sure that it simply drops right into that. And once you have it in there, then it's ready to go. It sits flat. You can see that's absolutely where it should be. You can take that bar that's there and simply push it all the way down, and it should be able to easily push just with one finger and lock right into place down there at the bottom. That's how hard it is to get the CPU actually installed on these newer systems. Very, very easy. Just keep in mind that you don't want to touch a lot of this. Keep your fingers around the sides of that processor. Make sure there's going to be no problems with any type of static electrical discharge or any other issues by touching the different components. So now that we've got it in place, we need to think about the other parts of the installation. Just putting the processor on the motherboard, you're not done yet. You also have to think about cooling the CPU. It's one of the hottest components that are inside of your computer. It can burn you if you touch it when it's doing a lot of calculations. It'll heat up really, really quickly. So we want to also put along with these CPUs and these processors a way to cool them down. So the first thing you're going to need is some thermal compound. This is going to put this type of liquid that is going to be a little bit more solid once it cools, once it gets onto the system, that creates a connection between the processor and the metallic heatsink that we're going to put right on top of it. What that really does is fill in all the gaps, and it makes a very, very simple connection there to go right between. It's important that we get rid of all those possibilities of air gaps here, and I put this statistic here to make you understand that air is about 8,000 times less efficient at conducting heat than a heatsink. So you want to be sure that heatsink really sits right on top of the processor, and there's no possibility of any air being between your processor and your heatsink. Once we have the thermal grease in place and we've followed our manufacturer's instructions on exactly how to put that on our processor, we then lay right on top of it these heat sinks. So now we've got a really good connection between the processor and these metallic heat sinks. They're going to take all this heat and distribute all of that heat out, really conduct all of the heat out onto these metal tins, these metal fan pieces that are on the top. And then what we're able to do is put fans right on top of those, so that all of the heat coming off of them is then having air blown right on them and cooling down that CPU as much as possible. Sometimes you aren't using air to do that, you're using liquid to do that, especially if you're overclocking or it's a very, very high-end system. Usually this is not seen in a lot of enterprise environments. Usually if it's a hobbyist type of environment, we're doing things like liquid cooling to make sure we're cooling it a lot faster than what we could do with air. Usually you have this block that sits right on top of your processor, and then you have some liquid inside of these tubes that then is going to go to a radiator that gets blown with a fan and then radiates that heat out, and it gets cooled with the fan, and then the liquid continues on back onto the block. Usually there's a chemical coolant in there, not unlike the coolant you would use in an automobile, for instance. So this is usually something that's not safe for you to drink. Sometimes some of them are poisonous. There are other coolants that are coming out these days that are not as poisonous or not as something you'd have to worry too much about on there, but they are liquid nonetheless. And sometimes having liquid near an electrical computing device, those two sometimes don't mix extremely well. So you want to be very, very careful about how this is going in and make sure there's no possibility for getting any of that liquid coolant inside of your computer. Let's see what we've learned about installing and configuring our processors. Our first question is, what metallic component helps dissipate heat using air? We added one of those right on top of our processors, and that would be our heatsink. Our next question is, what assists the thermal connection between the component, like our processor, and the heatsink itself? We added something to the mix, didn't we? We put something right between those, and that was our thermal grease. You might also hear it referred to as thermal compound. And our last question is, what kind of processor socket requires no pressure whatsoever during the installation of the processor or the removal of the processor? And the answer there is a zero insertion force socket, or a ZIF socket. Well, that covers our requirements for installing, configuring, and maintaining our processors from our 22702 section 1.1. Every single one of our A+ videos is absolutely free to watch online. You can also participate in our message boards and much more by visiting our website at freeaplus.com.